Right, so in section 1.3, what we're focusing on here are what we call the 12 basic functions. There are, of course, many more functions than 12, but most of the functions that we're going to deal with are going to come from some form of these 12 that we're going to study right now. Each of these slides has a different function on there, starting with f of x equals x, which we know is a line. We spent a fair amount of time working with linear functions in our chapter P. There are some interesting facts here. I'm not going to read through each of these interesting facts because they're also right straight from your book as well, so you can take a look at that at your leisure. But I do want to make a couple of comments about each of the functions. Okay, and I also want to talk about, probably the most importantly is, what is it about this function that we need to know? Well, first of all, we need to make sure that we can recognize the relationship between graph and equation. So if we see y equals x, okay, we just straight up need to know without the calculator what that looks like. Okay, we need to be able to produce that graph, okay, and talk about the features of that graph. And the features of the graph are these that I'm going to show you here in page 112 in your book. Okay. So they've done this analysis with the absolute value function, which is one of the 12. We'll see that one in a minute on one of our slides. Okay. But the things that we should be able to answer about all these functions, okay, besides being able to draw the graph, okay, or if we're given the graph, tell what the equation is, if you will. Okay, we should be able to tell what the domain is. In this particular case, it would be negative infinity to infinity. Okay, there's nothing that we can't take the absolute value of. If we liken that to our identity function down here below, okay, its domain, again, it's a line. It's not a vertical line, so therefore its domain is also negative infinity to infinity. Okay, we go from left to right. We don't stop going left. We don't stop going right. There's no issues with discontinuities, etc. Okay, the range here for the absolute value function, the range, okay, it goes as low as 0, okay, and then as high as infinity. The line down below here, of course, it does not continue going down, or does not stop going down, does not stop going up. So the range of this function, of course, is negative infinity to infinity. Continuous or not is a question we should be able to answer. Okay, this is, of course, continuous. There's no discontinuities that we know that we can see. The line, of course, is continuous as well. We should be able to tell when it's increasing and when it's decreasing. Okay, in this particular case, we're decreasing on the left branch, okay, from negative infinity to 0. Okay, increasing on the right branch, okay, from 0 to infinity. And you notice that they put brackets on the zeros here for increasing and decreasing. As I said, you can either have brackets or parentheses. I'd prefer parentheses, because I don't really think it's decreasing at 0. So I prefer that not to be bracketed. Okay. Of course, on the line down here, this one is increasing always, negative infinity to infinity. There is no decreasing for this one. There's no constant portions. Okay. Symmetry. This particular one is symmetric with the y-axis, making it an even function. Okay. This one is symmetric with the origin, isn't it? If I were to rotate this part 180 degrees, would I be on top of the other part? Okay. So this one would be an odd function, so we should recognize that. Boundedness, are there any boundaries? In this particular case, it's got a minimum value, so it's bounded below. The maximum value here is infinity, so it's not bounded above. The line is not bounded in either direction. It goes on forever, as we mentioned. Local minimums and maximums. In this particular case, we have a local minimum, as we can see here at 0, 0. The line doesn't have a local minimum or a local maximum. Okay. Horizontal and vertical asymptotes. Okay. In this case, this continues to grow, so no horizontal asymptotes here. Okay. Again, grow and grow in the negative direction, so no horizontal asymptotes for either of these. There's no vertical asymptotes either. We kind of covered that with their discontinuities. Okay. And then the end behavior. Remember, the end behavior is just a description of what's going on with the y values as x gets big and x gets small. Okay, in this particular case, as x gets small, okay, what's going on with the y coordinates? The y coordinates are getting really what? They're getting big. So therefore, the answer to this is infinity. Okay, and as we go off to the right, what's going on with the y coordinates as we get off to the right? It goes big also. Okay, so that would almost be the same thing for this one. As we go to the right, the numbers are getting big. But as we go to the left, our answer wouldn't be infinity, it'd be what? It'd be negative infinity, because they're going down in this particular case. Okay? So these questions, these analysis questions, are essentially the important questions that we should be able to answer about all the functions that we're about to see. Okay? So So any function that we look at right now, we should be able to answer any of those questions if they're asked of us. Fair enough? So this page 112 is important because those are the kind of things that we need to know. And I can tell you right now, in quiz and test, we're going to be asked these questions about these functions, and we need to know which ones have these properties. Okay. So again, we're not going to go through the entire analysis for every function, okay? But some of the questions that you're going to do in your homework are going to be just that. You're going to be answering questions about these functions. Okay, so I'm going to, again, quickly, just so we can see the relationship between graph and equation. Okay, the squaring function f of x equals x squared. Of course, we've had a lot of experience with that because it's a parabola. Okay. The cubing function, okay, again, the general shape. We call this one the reciprocal function, 1 over x. Notice there is an asymptote here, a vertical asymptote, because we can't let x equal 0 here in this case. Okay. Square root function, okay, is an increasing function. Notice there's nothing on the left-hand side of the coordinate plane because we can't put negatives into the square root function. Okay, so it starts at 0, 0 and increases as we go to the right. The exponential function e to the x, okay, we've had experience with that mostly in Algebra 2. Okay, it's an exponential growth function, of course. It has a y-intercept of 0, 1. If we plug a 0 into that, we'd get 1, because anything to the 0 power is 1. The inverse of the exponential function is the natural log function. Okay, so it also can't have negatives in its domain. Okay, we can't take the natural log of a negative number. Okay, it starts at 0. In fact, 0 itself is an asymptote, so it would be 0 with a parenthesis to infinity, domain-wise. Okay, trig functions, sine and cosine. Okay, we spent a lot of time on in Algebra 2 also. Okay. And as I mentioned, this is the one that we analyze the most here at this point today, the absolute value function. It's like a V shape. And then we have the greatest integer function, okay, which in your calculator is under the math menu if you want to graph this. The calculator doesn't do the greatest job of graphing this because of the discontinuities. It has a little bit of trouble with the discontinuities. But the integer, greatest integer function, all that is doing is when you put an x in there, it's rounding it down. So if you put a 0 in there, it's going to round it down to 0. If you put 0.5 in there, it's going to round it down to 0. So 0.10, 0.50, 0.70. And then once you get to 1, it rounds to 1, so then it'll jump up to 1. So this function has essentially an infinite amount of jump discontinuities, okay? Because every time you get to a whole number, okay, the y-coordinate jumps up. And then finally the logistic function. And we probably spend the least amount of time on this type of function, but we do need to know some of its behavior. So 1 over 1 plus e to the negative x. If you were to graph that with your calculator, you would see this general shape. Okay. Now, the good news about these 12 functions is that over the course of this next few chapters, etc., we're going to be spending a lot of time on each of these individual functions. Okay? Like I said, today what we're going to try to focus on is just some of the general properties, okay, of these. Okay? And then we're going to study these in detail, okay, as we move through this book. Okay? One of the questions we might be asked here in a few minutes in our homework says one of the functions has a domain, the set of all reals except 0. Okay? In other words, the domain is negative infinity to 0 and 0 to infinity. Okay, and if we look back at the pictures that we had there, which one has an issue at 0? Okay. This one has an issue at 0, but it doesn't have anything on the left side of the coordinate plane. True? So as we said, that would be the domain for this one. Okay. And if we look back at the one in question, it would be this one, wouldn't it? And this one goes from negative infinity to 0, and then from 0 to infinity. Okay, so that one has that particular feature. Okay. Alright. So, one thing that we'll also be doing today is taking a function like this. We have y equals negative x squared minus 1. And we're going to be just using our calculator to analyze it. Let's move the lights real quick again. So opposite x squared minus 1. So we can see the function on there. One question we might be asked here is which of our parent functions, or which of our 12 basic functions would this one be a variation of? What does this one look the most like? Yeah, the squaring function. It looks most like x squared, doesn't it? Okay. And like I said, this is just a variation of the x squared function. So on what interval are we increasing and decreasing? Well, it looks like we're increasing over on this side. So we say we're increasing from negative infinity to 0. And then we're decreasing from 0 to infinity. Okay. So one question we could ask about even, odd, or neither. Does this appear to be even, odd, or neither? Looks like it's got symmetry over the y-axis, so it would have to be even. Okay. Does it have any extrema? In this case, we do have an extreme value. It's going to be a maximum here. So it looks like I could use the maximum command to verify that, but it looks like 0, -1 would be the maximum point. Okay. And then we already answered part D. Okay, how does the graph relate to the graph of the basic function y equals x squared? Well, ultimately, it's been flipped over the x-axis, okay, and also moved down 1. It's been translated. Okay. So like I said, the relationship to the basic function graph, okay, is something that we're going to, with each of these different types, something we're going to explore in this class in further detail later on. Okay. All right. Right now, we're just going to basically do it by looking at the calculator and analyzing as close as we can by looking at what we see. Okay. Questions so far?